Okay, good afternoon, ladies and gentlemen. 131. Alright, so let's start from question 15, just a recap. Start from question 15. What is question 15 saying? Find the roots of each of the following quadratic equations subject to the given conditions. Find the roots of the following subject to the given conditions. Alright, so I'll start with a, x plus k squared is equals to 2 minus 3k. Okay, so we've been told that this particular quadratic equation has equal roots, but I do remember we did this question, maybe because we didn't just solve it. Okay, so first I'm going to expand this, or before I even do that, we're going to say x plus k squared minus 2 minus 3k is equals to 0. Okay, then I'm going to expand so that it's in standard form. Alright, so expanding this, we're going to have x squared plus 2k, x plus k squared minus 2 minus 3, k is equals to 0. Alright, so upon expansion, that is what we get. From this, the next thing that we need to do is we now need to arrange this in such a way that we can see the A, the B, and the C. So the A already is 1. You can see the A is 1, 2k is B, and this whole is actually C. Right, so we know that the sum of the roots is given as negative B over A. So in this case, since we have our B as 2k, so we have negative 2k, negative, so it's negative 2k over 1, which is just negative 2k, right? Then we have the product of the roots, which is C over A, but we have the product of the roots as k squared minus 2 minus 3k over 1. Okay, so this is k squared minus 2 minus 3k. So basically speaking, that is the product that we get. Alright, so we're now going to use the result which we have. I'm now going to use the result which we have. Based on the results that we have, we've been told that the values of which we are looking for is that the two roots are actually equal. Okay, so the given quadratic equation has got equal roots. The given quadratic equation has got equal roots. So because it has got equal roots, we're saying we're no longer dealing with just beta alone, but we now have alpha and alpha, right? So, alright, to this side we're saying alpha and alpha are the two roots in question, okay? That having been said, whenever there's beta, I'm going to replace alpha. So we basically have the sum of roots as 2 alpha is equals to negative 2k, because when you add alpha and alpha is 2 alpha. The product, you are going to have alpha squared is equals to k squared minus 2 minus 3k. Alright, so this is what we have as our product, that is what we have as our sum. Okay. Okay, so with that being said, we have two simultaneous equations which we need to solve simultaneously. So how do we solve these two simultaneous equations? So to solve these two simultaneous equations, what we're going to do is we're simply going to say make alpha the subject of the formula on one end. So we have alpha is equals to negative 2k over 2, which is just negative k. Okay. Then I'll say on the other side, I'm going to make alpha the subject. I'll place alpha in equation 2, so we have k, that is k squared is actually equal to k squared minus 2 minus 3k.